as an example, and this is an example that we will make use of, make quite a bit of use of in class. We have a brown bag. I have a bag of washers with some numbers written on them. And that brown bag is a bag that is approximately normal. So it serves as a process distribution in a demonstration that we'll do in lab. Approximately normal, it has a mean of 5, and it has a standard deviation of 1.715. Okay, and I know that because I'm the guy that wrote the numbers on the washers, and so I'm telling you that's the way the process is made up. Okay, so if, for example, I want to do control charting of, say, X bars, and for sake of argument I'm going to do that based on samples of size 5. What should be my control limits for sample averages? Well, my control limits for X bar, what do they become? Well, the lower control limit for X bar is set at process mean minus 3 standard deviations for the process over the square root of the sample size. And these are the numbers that describe the bag that I'm sampling from. So this is going to be 5 minus 3 times 1.715 over the square root of 5, and that turns out to be 2.7 if I do the arithmetic there, whereas an upper control limit for X bar is the same thing with a plus sign in there, and that turns out to be 7.3. And I would put a center line at 5, which is the process mean. Now notice that in order to come up with these control limits and this center line, I had to make use of these values up here. I had to make use of process parameters.